Welcome you all guys to Debugging Doubts. In today's topic, let us study about JK Flipflop. Before that, if you haven't watched my SR Flipflop video, then please watch it because if you know SR Flipflop properly, the JK Flipflop is very easy because 75% of the SR Flipflop is used in JK Flipflop. Here you can click the link above and watch SR Flipflop video. The important properties of NAND gate we have discussed in the previous video, that is RS latch using NAND gate. If you haven't seen the video, then you can click on the link and watch it.
If one of the input of the NAND gate is 0, then the output is 1 only.
This I have discussed in the RS latch using NAND gate. If you haven't seen the video, then you can click on the link and watch it. Now we'll focus on the JK flip-flop. I am showing you SR flip-flop diagram, right? Because here almost the JK flip-flop is same. So you can remember this diagram easily. I will show what changes you should do so that SR flip-flop will convert into JK flip-flop. First thing is from Q dash, you will darker this dot and go this way and connect it to S. Okay. Then from Q, you darker this dot and take this way and connect it to R. And S will be removed and written as J and R will be removed and written as K. This is JK flip-flop. Now I will show you the proper diagram. See, this is JK flip-flop. So it will be very easier if you know SR flip-flop. First disadvantages of SR flip-flop is, you can see here, when clock is 1, then for 3 of this input, you are getting some values. But for this, you are getting invalid. So JK flip-flop will solve this issue. That is, it will remove this invalid. You will get output this as Q bar and this as Q. So in the further video, you will understand it more clearly. Okay. Now coming to the JK flip-flop. First thing, we'll try to analyze and fill all the values. J is set and K is reset. For all the values, let the clock be constant, that is 1, because we know whenever clock is equal to 1, then only it triggers. So why need to look for clock is equal to 0? Because clock is equal to 0, the value will be hold, right? So we need not look at clock is equal to 0. Let us focus only on clock is equal to 1. Okay. Now we'll consider that is J is equal to 0 and K is equal to 0. What will be the output? From the first NAND gate, the output will be 1. And second NAND gate, that output will be 1. Why the output is 1? Because of NAND gate property. That is, if one of the input is 0, then output should be 1. Now when 1 and 1 is passed to the RS latch, what will happen? So it will remain the same. So whenever J is 0 and K is also 0, the output will remain same. That is, so Q will remain Q in the next state. That is, 0 will become 0 and 1 will become 1. Okay. Now next, take the second case. So your J will be 0 and K will be 1. So what will happen? So 0 means it will be 1 compulsory. Now here in the K, so from clock 1 will come here, right? And K will be 1. And from here, Q value, right? The Q value will go this way. So here it will be Q. So it will be 1 into Q and whole bar is equal to Q bar. So here it is 1 and Q bar going into RS latch. So first we'll consider the 1, okay, here. So 1 and this input will be Q bar. 1 into Q bar whole bar is equal to Q bar double bar is equal to Q value. So now this Q value will go this way and here it will be Q and here it will be Q bar and this will be Q into Q bar and whole bar is equal to 0 bar. That is Q into Q bar is 0 and is equal to 1. Now here we are getting 1. Now it will go this way. Now here new value will be 1. Okay. So here it will be 1 into 1 whole bar is equal to 1 bar is equal to 0. So here the new output will be not q but 0. Now this 0 will once again go in this way, and here it will be 0, and 0 into q bar whole bar is equal to 0 bar, that is equal to 1. Once again we got the same value, that is 1, and the JK flip-flop is now balanced. So I will write the final output, that is, so for j is equal to 0 and k is equal to 1, the value in the q will become 0. Whether the value of q is 0 or 1, the output will change to 0 itself. You know this, right? When reset value is set to 1, the output q should be 0. This is what I said in the previous video. Now consider j is 1 and k is 0. K is 0 means your output will be 1. And here the output will be 1 is from the clock, 1 from j. So 1 into 1. And here q bar will come this way. Okay. So it will be q bar. So 1 into 1 into q bar and whole bar is equal to q bar double bar is equal to q. So this is q now. Okay. Now I can consider from any gate. It doesn't matter actually. So you consider that q bar will go here. Okay. Q bar. Then here it will be q into q bar whole bar is equal to 0 bar is equal to 1. So 1 will go here, and it will be 1 into 1 whole bar is equal to 1 bar is equal to 0. Okay, so here it is 0 now. So now this 0 will go here. Now this input will change. Okay, here it will be 0. So 0 into q whole bar is equal to 0 bar is equal to 1. Once again we got 1. So the JK flip-flop is balanced. So I will write the output value. That is, when j is equal to 1 and k is equal to 0, whatever may be the previous value, that is 0 or 1, it will change to 1 itself. Because you can observe here, set is 1, then output is 1 itself. Now we'll consider on the main topic. These all things you can write from SR Flipflop table itself. I'm just explaining it, okay? When j is 1 and k is 1. In SR Flipflop, it was giving you forbidden or invalid state. But in JK Flipflop, we'll solve this way, okay? So here from clock it is 1 and j is also 1. And from here, the q bar will go this way, right? So this is q bar. And from here, the q value will go this way, right? So here it is q. Now, here what will happen? 1 into 1 into q whole bar, that equals to q bar. And here what will happen? 1 into 1 into q bar whole bar is equal to q bar double bar is equal to q. So in RS Latch we getting q and q bar. So suppose now q bar will go here, okay? So it will be q bar. Now here what happens is q into q bar whole bar equals q into q bar is 0 bar, that equals to 1. Now this one value will go here. So what happens? So here it is q bar into 1 whole bar, that equals to q bar double bar, that equals to q. Now this q will go here, and what it happens? Q into q whole bar, that equals to q bar. So now it will be not 1 but q bar. Now once again the q bar will go here. Then what it happens? Q bar into q bar whole bar equals q bar double bar equals q itself. So now the gate is balanced. So what is the output here? So q became q bar and q bar became q. That is why when j is 1 and k is 1, whatever may be the previous output, it will negate it. That is 0 will become 1 and 1 will become 0. This is how you can fill the truth table for JK flip-flop. Here you can see the truth table. You can read it. Now we'll compare with SR flip-flop. In the SR flip-flop, you can see whenever the clock is 0, it will be in the same state, that is hold state. So no need to observe that. When clock is 1, for these 4 cases, we'll see. So when S is 0 and R is 0, you can see it is in hold state. So when J is 0 and K is also 0, it will be in hold state. And see the second point. When S is 0 and R is 1, that is J is 0 and K is 1, it will be in reset. So the output was 0, right? So we got 2 times 0. Now next consider when S is 1 and R is 0. When J is 1 and K is 0, it is set state. So value will be 1. Then when S is 1 and R is 1, last state, here the value will be negated. That is Q bar. This is how easily you can remember JK Flipflop truth table from SR Flipflop truth table. Coming on to the JK Flipflop excitation table. How can we fill it? So what is excitation table? This is previous output and this is current output. Okay, now let us analyze. So when output changes from 0 to 0, what is the J and K value? You can see here it changed from 0 to 0 and here it changed from 0 to 0 in the truth table. So the J and K value are 0, 0 and 0, 1. So J value is compulsorily 0 here and K value is 0 or 1. So it will be X. Okay, this way we need to write. Secondly, when output changes from 0 to 1, you can see in the truth table, right? Where it is 0 to 1 and 0 to 1. What is the J and K value? That is 1 and 0 and here it is 1 and 1. So J value is compulsorily 1. So I'll write 1 and K value is 0 or 1. So I'll write X. This is how you can represent. Now when it passes from 1 to 0, let us see in the truth table. So 1 to 0 it is here and 1 to 0 is here. So you can see these two columns, right? So the K value is compulsorily 1 but J value is 0 or 1. So I'll write it as X. This is how you can represent. And finally, when it output changes from 1 to 1, you can see remaining 1 to 1 and 1 to 1. So J and K value is 0 and J and K value is 1 and 0. So K value is compulsorily 0 but J value is X, means 0 or 1. This is how you can write excitation table from the truth table and it is very helpful when you solve the counters. Here you can clearly see the excitation table. In exam you need to draw logic diagram, then truth table and excitation table. Mainly the first two are considered. This was all for today and if you like my video then please like it, share it and please subscribe it. Thank you all for watching.